Okay. So in the mechanism now of why in the preparation of polystyrene, we have shown that in the head to tail manner of preparing our polystyrene, we were able actually to utilize a 2-degree radical rather than a 1 degree radical. Here in this process, you have your 1-degree radical. Here you get actually, we were able to utilize 2-degree radical, which is more stabilized than the 1-degree radical, and that is the reason why the polystyrene proceeds in its polymerization reaction via the head to tail bond formation via radical mechanism, of course. So problem. So another kind of polymerization reaction actually proceeds via the acids. No, alkenes also polymerize when they are treated with strong acids. But in this case, this is very unlike what we have learned using the radical polymerization reactions, because in the mechanism following this polymerization kind of reaction, we don't actually produce radicals, but instead we were able to produce carbocations. So here in the polymerization using acids, it doesn't follow radical reactions. But the one reason siguro that the author included this in this chapter is that we are talking about polymerization reactions of alkenes, but alkenes also can actually proceed its polymerization reactions, not via radical reactions, but also using acids. So again, in this case, alkenes polymerize and they are treated with strong acids. Okay, and the growing chains in the acid-catalyzed polymerizations are cations rather than radicals. So I'm trying to emphasize here that polymerization using acids proceeds via the formation of carbocation. Whenever you have a double bond using an acid, in its as catalase, we always produce carbocations. We have learned that with alkenes. Okay. So here, the mechanism, we'll look at the mechanism of the reaction. So for example, we prepare the polymerization of isobutylene. Okay, what is that isobutylene? Isobutylene is this one. This is your 1, 2, 3. This is your isobutylene. So here in the presence of an acid, BF3 is our acid. What happens is that we actually produce a carbocation. So the first step is the Lewis-base acid reaction. No? So this BF3, we've learned that BF3 is always the Lewis acid. Isa ng Lewis acid. Again, it is the reagent that accepts an electron pair. This becomes, water becomes our Lewis base. So here, the electrons, boron here, accepts electrons from our oxygen here. From oxygen here, you have your O, you have your boron, F3O boron bond. Of course, since he formed an oxygen boron bond here, and you notice we utilize the electrons on the oxygen, okay, count on the number of electrons, the number of bonds and unshared electrons. Oxygen here is passively charged. Okay, passively charged. Wala gibutang, it's passively charged. And boron here contains 4 bonds without an electron. Group 3 minus number of bonds 4, it becomes negatively charged. So dapat na siya positive here, kani positive. Siguro nakita. Na-cut pag-ayo later. So na siya positive ha. Like this one, na siya positive. Okay, in the presence of an alkene, in this case, we are using isobutylene. Okay, so asa man mo add, this is just an addition reaction that we have learned in the previous chapter 8. Okay, so nakay double bond, mo add siya, mo react siya, this becomes our nucleophile, no? It forms, this becomes our source of electron, no? So si carbon here, si H2 man siya, will form a bond with hydrogen here utilizing the pi electrons. So when it forms a bond here with hydrogen, okay, the electrons, so oxygen and hydrogen, will go to oxygen, and you will actually eliminate. You will actually have your VF VF3 here, OH. Now you will have your electrons from the OH going back to O. And then what happens to your isobutylene? You get a carbocation here because we are utilizing the pi electrons to form a bond here. You get a positive, a tertiary carbocation. So once you have the tertiary carbocation, this is just an addition reaction. No, it proceeds with polymerization via carbocation. So what happens on addition reactions, can we use an electron? The electrons from the pi bond to form strings bond here. Okay, so maintain lang ng 1, 2, 3, no? Carbon, 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 carbon here. And this one too, maintain na siya, no? This one and this one. So line na natin ni dapat let's say green. This is where the bond occurs between here. So a bond between this tertiary carbon and this carbon is being formed using the pi electrons. Okay, so all the electrons that is used to form a bond, kaning a bond, comes from this pi bond. Okay, so what happens is that kaning a carbon, ma-deplete na siya og electrons because we're using all the electrons to form a bond here, it becomes positive. So once it becomes positive again, we just repeat the process. We use another mole of our alkene, and then we expand, etc. And so here you actually have your polyisobutylene. Proceeds with that. Okay, so the catalysts used for the cationic polymerizations are usually Lewis acids, like BF3, in a small amount of water. And the polymerization of isobutylene, we were able to illustrate how the catalyst BF3 and water functions to produce growing cationic chains. So again, we're able to prepare a polymer here, but what is the difference with the polymer? Here, it doesn't follow the radical reactions or the radical mechanism. No, we proceed with addition reaction via the carbocation, in the same way that what we have learned in chapter 8 katong sa alkenes. So the catalyst used for cationic polymerizations is already redundant. So another way of preparing proceeding with polymerization reactions, you can also use strong bases. Aside from strong acids, or acids rather, Lewis acids, you can also use strong bases to proceed with polymerization reactions. So what are our strong bases? So alkenes containing electron withdrawing groups, some of the electron withdrawing groups, like this one here, kani. Carbon here, CN. N is an electronegative atom. Now it's carbon triple bond N here. This becomes an electron withdrawing group. There will be an inductive effect, no, with an electron withdrawing group here. It draws electrons pa ingon sa iya. Let me share. Wait now. What is that electron? Checking electron. So I just want to emphasize first before I proceed to this reaction. I want to emphasize on then of this acrylonitrile, no? So here becomes our this one, it's actually C triple bond N. It's an acrylonitrile. It's you have here, and here you have a nitrogen, which is very electronegative. Okay, so it draws electrons to itself. I'll put an arrow. So having an electron, this one, having an electron, because you have a negative oxygen here. So nitrogen is electronegative, and you have here the acrylonitrile, the nitrile group rather. We're able to identify this one as an electron withdrawing group. An electron withdrawing group. So by virtue of nitrogen being an electronegative atom. So when you have an electron withdrawing group, this, for example, the structure of your molecule, here from carbon and nitrogen, no, carbon and nitrile. Of course, you expect that the dipole is paingon kang nitrogen. From carbon and carbon, this whole group nitrile, no, the dipole will be paingon kang CN. Okay, so because this one's paingon kang CN, this carbon here becomes partially positive na, di ba? Relative to this one, yung electron density is much more depleted because of the electron withdrawing. Paingon dito, you will have the electron withdrawing inductive effect. Okay, masalatan. We actually have this electron withdrawing inductive effect by virtue of this electron withdrawing group. So that between carbon and this group, nitrile, no, you can actually have a dipole. So I'll use another arrow. You actually have a dipole, paingon kang CN. And once you have that dipole there, you can also see the dipole between this and that, paingon kang dira. Paingon ani nga carbon. So this is inductive effect, no? There is an electron withdrawing group, paingon kang CN, and because this one somewhat is depleted with its electron density because of this inductive effect, mo transfer ang induction of inductive effect, no, diri pod nga bond. So paingon po dito in such a way that kani siya nga end, this end here becomes the carbon hydrogen. Tangan natin na siya. Oh, which one is a good color? No, you have your this end here, it's green na lang. This end here becomes somewhat partially positive. Somewhat partially positive. Klaro ba akong partially? Kani nga end diri. No, again by virtue of electron withdrawing, klaro ba, inductive effect. Okay, so once you have here, balik na ako ni siya. Okay, so because this one is somewhat partially positive here by virtue again of the green na lang na ako because of this group, no? So it can actually this nucleophile, no, which is electron rich, no, can form a bond here, can attack this carbon here because somewhat it becomes depleted with electron density, this carbon here. So you form a bond here. Once it forms a bond here, what happens is that red, the electrons from the pi will go anikang carbon. So let's use the red. So you use 2 arrow because this is not radical, 2 arrow. And you have an electron that here. So once you have this, a carbon anion, okay, we have, kapara na po nato siya with another alkene. In this case, our alkene is an acrylonitrile, kani, this one. So it will again attack this carbon here, which is somewhat partially positive, again, by virtue of electron withdrawing inductive effect. Pag-attack nato kang carbon, here, using this, gamito nato ni siya to attack this one. So what happens, because we're using the electrons, gikan aning carbon and ion, the electrons coming from this double bond here we go, ani diri, you get your that here. Okay, and then we just repeat on the cycle. So, baliktan, dugay na ko. In the formation, in the polymerization reaction of alkenes, aside from the polymerization using the Lewis acid, we can also proceed the polymerization using a strong, using a strong base. No, in this case, you have the liquid sodium amide. You have the sodium amide, rather, it's a salt in liquid ammonia. And here we, in the mechanism, we actually produce carbon and ions. Okay, what's here? The remarkable superglue is a result of polymerization. Can you have your methyl methyl cyanoacrylate, rather. A solution contains methyl cyanoacrylate. The methyl cyanoacrylate can be polymerized using an ion such as hydroxide, but it's even polymerized by traces of water. Polymerization here. These two objects, unfortunately, have often been two fingers of person doing the gluing. Show how the metal mechanic would undergo an ionic polymerization. Again, when you look at this structure here, you have kani CN, which is again an electron withdrawing group. Electron withdrawing group. What do you mean by an electron withdrawing group? It has an ability to withdraw electron density paingon sa iyaha. So if it is bonded to carbon here, it withdraws electron density paingon sa iya kaninga group, no? So what happens sa iyang silingan nga carbon is that it will allow electron withdrawing inductive effect. So naay induction. So kaninga bond, because kani ma-deplete na with carbon with electron density, this bond also follows the inductive effect, and this carbon here becomes partially positive. So much more for this, no? When this carbon contains C double bond O oxygen, this group also is an electron withdrawing group. Can you see? So since this you have an oxygen here being an electron withdrawing group, this carbon and carbon here will also experience an electron withdrawing inductive effect, no? So ang electron density gikan ani nga carbon, and this carbon will also go paingon diri nga carbon. So in effect, kani siya nga carbon becomes partially positive. So in effect, again, because this becomes partially positive, it will obtain another electron density from its neighboring bond, no? So it gets electron density from here para ma-compensate ang iyang partial positive charge here by virtue of the electron withdrawing group here. So in the end, kinsa man ang ma-deplete this end here, carbon. So there are two groups actually that promotes inductive effect, making this carbon here to be partially positive. Okay, this group, the CN and the COO. So this group has the we refer them as electron withdrawing group. That this here that induces electron withdrawing inductive effect. And this carbon here becomes exposed, becomes partially positive, na dali ra siya ma-attack with a nucleophile. So example, hydroxide, no? Say ko andiriya na hydroxide ion. So if this one's being attacked with an hydroxide, no? Of course, the mechanism is the same as we have discussed before. Once this one forms a bond with this carbon, being somewhat partially positive by virtue of electron withdrawing inductive effect of these two groups here, the electrons from the double bond here mo anhi kang kaninga carbon. Okay, and this you actually obtain your carbon and ion. So you form a bond here, the pi electrons will go here, and once you have your carbon and ion, you just repeat on the process. You form a bond here, the pi electrons will go here, you produce your carbon and ion, and so on. Okay, and that is how the gluing occurs once you have your methyl cyanoacrylate in the presence of a base. No, so you have surface traces of water found on the surface. You can glue it together. You can glue. You can have the glue adhesion. No, you just have to use water, of course, in the with a small small hydroxide ions. Okay, so I think that the last part is chapter 12, and it should be so that will be the last part, which is other important radical reactions. So radical mechanisms are important in understanding many organic reactions. We shall see other examples in later chapters. So let us examine a few important radicals and radical reactions here. You have the oxygen and superoxide, the combustion of alkenes. We have some examples now with molecular oxygen and superoxide. One of the most important radicals that we encounter every moment of our lives is the molecular oxygen. What is molecular oxygen? The one that is in the ground state is a diradical with one unpaired electron on each oxygen. So as a radical, oxygen can abstract hydrogen atoms just like other radicals we have seen. So we have this auto-oxidation process. Let's see if we have the auto-oxidation process. Okay, so you have your molecular oxygen here in the presence. How does it happen? No? The enzyme superoxide dismutates, no? Once you have this peroxide reactions reacts with a proton, an acid, no? Catalyzed by you have your superoxide dismutase. It's a protein and can actually convert to hydrogen peroxide. So once you have your hydrogen peroxide, no, in the presence of catalase, you can have your water and oxygen being released. So maybe you can read on the 10.12. There should be an auto-oxidation here process. Anyway, the auto-oxidation process actually is just an application. Let me see. Anyway, so I would like you to read on the last one. On the molecular oxygen and superoxide that we actually see in cells, no? On this process. So the read in that, and then there's this auto-oxidation process. In the auto-oxidation process, they actually use we actually involve our polyunsaturated fats, no, like carboxylic acids, no, having a double bond. Yeah, we have already discussed that one. In the auto-oxidation process, in the presence, what happened here is that you have the oxidation process, this auto-oxidation, because in the presence of the radical, no, you have the linoleic ester here, actually have, in the presence of light, can actually disintegrate this carbon hydrogen here, in the presence of a radical, but you actually get a radical here. And once you have a radical from our alkene, from our fatty acids, can proceed with its auto-oxidation. And in the presence of light, dili mo siya complete na mechanism. I will show you next time for this. So you actually have your part here where This is the auto-oxidation process, but I was looking for the termination step. Okay, you have the chain propagation, you have the radical here. Notice here that you have your radical. In the presence of radical, you have the auto-oxidation. You produce another radical here, radical, and you have your peroxide here. In the chain propagation step, you have your peroxide, and you can actually form a bond with your fatty acids, radicalized fatty acids here, and you produce another radical. Once you have your radical here, your peroxide radical, your fatty acids can abstract protons from your fatty acids here, and you get a hydroperoxide. So this is the process that we see actually, no? The auto-oxidation of our fatty acids example here is it's the linolate ester here. And this is a common reaction that we see when you have rancidity of foods, no? Unsa pa, spoilage of food, unsa pa. Aging process. This is an example of the aging process, or when you have the oil spoil, and so on. And for that reason, that whenever we have food products, no, we want to prevent this kind of auto-oxidation, no, that promotes spoilage of food due to the auto-oxidation process. Makabantay mo anang kuan dali ra siya mag-rancid, na for example kanang mga oil, especially ng imong mga kanang sa coconut oil, dili siya mag-rancid. We want to prevent that rancidity, or even sa atong foods, that we have to add the antioxidants. For example, your vitamin E, BHT, you have this, can read on this. And probably next meeting, I will show you how these antioxidants could eliminate on the auto-oxidation process. And for that reason, that you also add on antioxidants, no, sa ato ang mga cosmetic products, especially kanang atong mga skins na oily kay siya in the presence of UV and light, no, it will proceeds with this kind of auto-oxidation process. It promotes aging, and for that reason that we want to prevent aging sa atong skin, we have to add antioxidants. So maybe in the next, you can read on this chemistry of antioxidants, and probably in the next meeting, I can show you on the mechanism of how the antioxidants can prevent the auto-oxidation process as well as the aging. Okay, so that ends our session. Murag nalangan na hinuon ko. And next meeting, we'll have chapter 11 already. Okay, so that ends our session for today. Kamura de duha Shaira and Ronald. I'm not sure. Asa man ang uban? Pa sila ka move on sa election? So kaganina na ay 7 kabuok. Are you listening?
Yes, ma'am.
Kaganina na ay 7 kabuok nga nag-indicate. Unya karon na ray duha. Igor sila nag-attendance. So pagtanggalo na ko ning ilang attendance today. Anyway, so mao to tong lesson, and next meeting we'll have another chapter to discuss, and maybe I will introduce on just the mechanism of how the antioxidants could prevent the auto-oxidation process, which is a radical reaction that would be present in most organic substances, even as in our human body. No, we always proceed to the auto-oxidation process in our skin. So that's why whenever you're exposed to the sun, and if you have an oily skin, you always have to cover your face, no, to prevent the auto-oxidation, because in the presence of light and UV, no, we always can easily produce radicals on our body, and it proceeds with auto-oxidation. And we want to slow down aging with our skin, right? And that's why we have to use antioxidants. Also with, again, our foods, no? We have to prevent the spoilage, especially kanang mga preserved foods. And you will look at the preserved foods, in yung mga ginakaon, it always has the not the vitamin E. It has the BHT and BHT radical. And you can see on when we go to aromatics like phenols, you can see ngano siya nga, you can read in this kaning the chemistry of antioxidant. Nga naman siyang what is in their structure that would actually cause them to prevent the auto-oxidation process. Okay, so that ends our session and see you next meeting. Do you have questions?
Thank you, ma'am.
Thank you.
Okay, bye.